Hi, my name is Clarisca Laurencia. I'm a student from Binus International University, majoring in Information Systems. Today my video will be about a database in a movie shop. In my previous video, remember how I talked about how difficult it is to manage a movie shop with thousands of different movies without a database? In this video, I will talk about the database design and the application I created for the database management. Firstly, I'll talk about the conceptual data modeling. A conceptual data model is a map of concepts and their relationships with one another, which is used for database. Let me divide this into two parts. Firstly, I'll talk about the tables related to managing the movies, and then the tables which are related to managing the transactions. In the data, we can see the cardinality between the director and a movie table. One director can have many movies, but one movie can only be directed by one director. The relationship is directed. Next, we can see that one shelf can contain many movies, but a movie can be kept at one shelf only. The relationship between them is kept. In production company, one company can produce many movies, but one movie can only be produced by one company. Now we are in the part where we talk about the tables that manage the transactions. We can see that movie has a relationship with transaction line. The transaction line refers to the movie table to get the price. One transaction line can only have one movie, but one movie can have many transaction line. Transaction line is within the transactions. One transaction line can only have one transaction, and one transaction can have many transaction lines. Next, a customer can place many transactions or order, but a transaction can only be placed by one customer. Lastly, a staff can manage many transactions, but a transaction can only be managed by one staff. Now, we'll move on to the physical data modeling. This is a representation of a data design which includes the table structures, like the data type, the primary key, foreign key, and the constraints. In this data model, we can see the data type allocated to each column in every table. Furthermore, we can also see which one is the strong entity and the weak entity. For example, the movie table is a weak entity, since it relies on director, shelf, and production company tables. Same goes for the transaction table, where the table can exist with a transaction line, customer, and staff. Lastly, the logical data model shows a detailed representation of an organization's data. The one that is underlined are the primary keys, and the one with the hashtag sign are the foreign keys. Normalization is the process of organizing the attributes and relations of a database in order to minimize data redundancy. Okay, firstly, we will take a look at the UNF or the unnormalized form. We can see that this table is pretty messed up, where one customer can buy more than one movie, and the staff can manage more than one transaction, two movies having one production company, and so on. There are too many redundancies in this table. Now let's take a look at the first normalization form, or the 1NF. Firstly, I removed the customer name and the staff name from the movie specification table. The movie specification table is just a table to describe the movies, which is why we can see the director name, shelf name, the production company name, and their price. I separated the staff and customer into two different tables. The staff table stores a proper record of the staff, and the customer table stores the proper record for the customer. However, this is not sorted fine as of yet, because it will still create a confusion if one director can direct many movies. This will create a redundancy. Now let's take a look at the second normalization. At this point, we already assigned the movies an ID, and the director name, shelf name, and production company name have been substituted by director ID, shelf ID, and production company ID. A better description of the movies has also been included by adding attributes like stock, genre, and year of release. Now, director, shelf, and production company have their own tables. Each attribute clearly describes the table. For example, the director table is constituted of the name, ID, genre, and origin. The customer and staff table remains as it is, but this creates a problem if the manager wants to track the transaction. It will be difficult for the manager to track which staff has managed which transaction and how much did a customer spend in a transaction, and which customer engaged in which transaction. This problem will be solved in the third normalization. In the third NF, the movie, director, shelf, and production company tables remains the same. However, we can see that we have modified the staff and the customer table by eliminating the column of total purchase and transactions done. Instead, we have made two new tables, which are transaction line and transaction. The transaction line table is used to see the quantity of a movie being purchased within a transaction. The transaction table helps reduce the confusion for the company while managing their transaction data. Now they are able to see which customer was engaged in the transaction and which staff managed it. And they can also see the total for each transaction that had occurred. Now we have reached the last bit of the video, and I want to show you a Java application that I've created in order to ease up the database management. Since not all the staff inside the movie shop are able to code using SQL language, or even code at all, this application will help the staff to manage the data. For example, when we want to insert a new data, we press 1, and then there are a couple of options that come out. For example, if I want to actually insert into a customer record, I'll press 3. And firstly, I will insert a name, for example, Laurencia. And her gender is female, and her contact number will be something like this. And there we go, it's inserted. Now we want to check whether she's there or not inside the data, so we can check it through. Okay, 1. We'll continue the program again, and now we can actually choose to select all the data. And actually, I want to see the customer record again. I want to check Laurencia, right? Right, she's there for 1008. Next, I will try the other features that are available here. For example, if I want to update the data, press 3, and the customer data, for example. I don't like Laurencia just now, 4008, right? Let's choose a new name, for example, Leo. And his gender is a male, of course. New contact, okay, any number. There you go. Now let's see whether Leo is updated or not. 1, go to 2. And we're all selecting all the customer record. And there you go. Leo is now in 4008. Now let's try another function. Okay, now let's try feature number 4. This time we are going to delete a transaction line. We can only delete the transaction line because transaction line ID is not a foreign key anywhere. This is why it is possible. Okay, now let's try it. For example, now we want to delete the transaction line. It's the value. Now please insert the ID you want to delete. Okay, let's see. 6002, for example. I don't like that. There's a mistake. Insert it, and there you go. Data is updated. Okay, let's check it in the MySQL if it's deleted or not. We'll try to execute it again. Yes, it is deleted. I'll do feature number 4 later on, so we'll try feature number 5 right now. Search for a data. Now I want to search for a customer record. For example, customer number 4007, that's the ID. There you go, Laurencia is there. Okay, now let me try number 6. I want to print all the movie list with the ID. There we go. Works really well. Now let's view all the history transaction. This will enable the manager to see what were the past transaction that has occurred. We can actually also see the date of pay and the total. And as a manager, we also want to know what is the total income for the whole month. Let's try that. Okay, number 8. There you go. We can see the total income here, 89 890,000